So I welcome you all to another presentation, that is lecture number 24. So we are going through time response analysis of a control system, which we have seen in our previous lecture, that is lecture number 23. We have briefly seen that what is a time response analysis. So what a time response? Okay, so basically the time response is nothing but the output of any given control system in terms of time domain, and that particular time response is consisting of two important parts. One is the transient response, second is the steady state response. And then we have seen in our last presentation the various basic standard test signals, out of which we have seen step input signal means step signal, and then ramp signal, and then parabolic signal, and impulse signal, and then sinusoidal signal. These are the common signals that we will use in this control system in time domain response analysis. So in our previous lecture we have seen the step signal. Today we will see the signal ramp signal. This is the another important type of input signal, which is a standard test signal, normally can be applied to a control system. So how a ramp signal is defined? Just like as we have seen in our previous presentation, here also. So the ramp signal can be defined as, R of t is equal to, it is called some a into t, basically a into t, and it is for t is greater than or equal to 0, and it is 0 for t is less than 0. That is the definition of a ramp signal. Okay, R of t is our input, that is what ramp signal is equal to a into t. A is magnitude. Okay, a is the magnitude, where t, so R of t is equal to t. T is the function R of t, that is the definition. This is exist for t is greater than or equal to 0. This means that ramp signal is nothing but according to this definition. So the signal will increases linearly with respect to time. Means graphically the ramp signal can be represented like this, can be shown. This is your time. On x-axis you will take time, whereas in y-axis you will have your R of t. Means for t is greater than or equal to 0, means it is 0 basically, and it is gone to 1, 2, 3, and so on and so forth. This it can goes up to, you can say up to, this is plus infinite. It goes on up to plus infinite. So means for t equal to 0, so it starts at 0 and it goes ramp signal goes like this. This is what your ramp signal. So the input signal linearly increases with respect to your time. As your time goes on increases up to plus infinite, your signal will be increases like this, in this way. This is what your ramp signal. This is mathematical expression, mathematical definition of a ramp signal, whereas this is the graphical representation of your ramp signal. So this type of signal also be used as a standard test signal for any given control system. Then we will see what is the Laplace transformation of R of t. What is the Laplace transformation of r of t. If you take the Laplace transformation for this ramp input, how it could be. So as we have seen in our previous presentation for a step input signal, in the same way here also. And here A is the magnitude in general. A is the magnitude in general, and say for example the special type of this ramp signal is a unit ramp signal. Okay, so the case special case of ramp signal is nothing but it is unit ramp signal, you can say unit ramp signal. This is the special case of ramp signal. The special case of ramp signal is unit ramp signal, where unit is nothing but your magnitude, whatever the magnitude you have mentioned there, that your magnitude becomes 1. That's all. That's all. This is in general, this is the general definition of a ramp signal. If the magnitude A equal to 1, then that is called as unit ramp signal. Okay. Now, let us see what is the Laplace transformation of this r of t. The Laplace transformation. So, Laplace transformation of r of t is equal to what? This implies, as we have seen in our last presentation, Laplace transformation of r of t is nothing but is equal to, what is the definition? What is the definition? General definition of, have you remembered it? It is nothing but 0 to minus infinite e power minus s into t into r of t dt. This is in general, this is called unidirectional, or sometimes can also be called as unilateral Laplace transformation. If you take the range of the limits from minus infinite to plus infinite, then that is called bidirectional, or otherwise also called as bilateral Laplace transformation. Bilateral, unilateral. Uni in the sense you will have 0 to infinite. This is the lower limit, this is the upper limit. The integration will take place from 0 to infinite, that is called unilateral, whereas bilateral means it covers the total minus infinite to plus infinite. This is the standard definition of a Laplace transformation. And if you see from the mathematical background of this Laplace transformation, there are certain important properties are there for this Laplace transformation. So those I will explain you at a later stage, because it is not a mathematical subject. So here we will concentrate whatever is the required information only. So here we will use one of the important property of a Laplace transformation, that is nothing but, let us you please remember this, Laplace transformation of t power n. This is one of the important property of a Laplace transformation. Laplace transformation of t power n. T power n is nothing but your f, any function. T power n is nothing but any function f of t or x of t or r of t. Okay. Laplace transformation of t power n is equal to, it is called n factorial by s power n plus 1. Please remember, this is very, very important property of a Laplace transformation. This is very, very important property. Laplace transformation of t power n is equal to, here you need not to remember all the standard definition of Laplace transformation. In fact, in competitive examination, they will not ask you about the standard definition. Very in rare occasion they may ask, but most of the time you will be asked the problem. Basically they will definitely give, you can expect this t power n, or they will give you some this kind of some other function, is it not? So So for this, Laplace transformation of t power n is equal to n factorial. This is called factorial, n factorial by s power n plus 1. If you apply this property, this is one of the important property of Laplace transformation. If you apply this property to our function where so if you apply this property to this input signal, ramp signal, then how it could be? Let us see. Because these are the very basic information that you must know before going to in a deeper concept of the time response analysis. So Laplace transformation of r of t, nothing but our r of t, this is equal to Laplace transformation of, okay, what is r of t? It is a into t. Clear? I am finding the Laplace transformation of input r of t. In second step, Laplace transformation of our r of t is nothing but your at, and this is equal to a is some magnitude, it is a constant, take outside a, take outside Laplace transformation of t then. Clear? This implies a into, this is actually what is our known property of Laplace transformation? T power n. So here it is in the form of t power n. Here nothing is given there, no? Therefore, if nothing is given, you can assume that t power, actually if you compare with t, actually t power n is there, but here nothing is there, nothing but n is equal to 1, because 1 is there actually. Not required to mention 1, because if nothing is there, you definitely by default it is 1 only. Therefore then it comes, what is that? N factorial by s power n plus 1. This is what. Further, this implies a into n factorial. What is n here? Here nothing is there, 1. N factorial means 1 factorial. 1 factorial by s power n is 1 only, 1 plus 1. This equal to, this implies, what is that? A into 1 factorial, nothing but 1 into 1. Is it not? Have you remembered? 1 factorial means this is equal to 1, starts from 1, and what is after, I mean, it decreases. So there is no, 1 is minimum. Normally, we will not consider 0. Okay, only 1. 1 factorial means 1 only. And similarly, 2 factorial means that is 2 into 1. So higher to lower it goes like that, 2 into 1. Say 3 factorial means 3 into 2 into 1. Is it not? 3 factorial means 3 into 2 into 1. Like that, it goes on decreasing. Therefore, 1 factorial nothing but 1 only. Therefore, so here a into 1 factorial is nothing but 1 only, 1 by s power 1 plus 1, that is 1 by s square. That is what your answer. Therefore, the Laplace transformation of your r of t is equal to, finally you can write here your answer as, it is a into 1 by s square. That is your answer. Basically, Laplace transformation of your r of t is equal to, so this is what your answer, a by s square. And if you consider that a value is 1, means if a is 1 nothing but, then the name of this ramp signal becomes unit ramp signal. Unit ramp signal. Therefore, for unit ramp signal, for unit ramp signal, that is nothing but your magnitude a becomes 1, then obviously r of t is equal to, straightforwardly it is t only. In that case, Laplace transformation of r of t is equal to, it is Laplace transformation of t, this is nothing but, it is t power n, here n is 1, therefore 1 factorial by s power 1 plus 1, it is 1 by s plus 1 means s square. This is what I just explained you. 1 by s square, remember that. Therefore, in previous presentation, that is in lecture number 23, we have seen the first signal is the unit step signal, I mean our simple step signal, where we have seen unit step is nothing but 1. R of t is equal to 1 only. And if you take the Laplace transformation for that, it is 1 by s. Laplace transformation of step signal is 1 by s, whereas ramp signal is 1 by s square. 1 by s square. Remember that. 1 by s square. Now see the third signal, that is ramp signal is the second one, and third one is the parabolic signal. Parabolic signal. The third one is the parabolic signal. What is parabolic signal? Parabolic signal is nothing but, so it increases in a parabolic nature. And before that, we just define the definition of this parabolic signal. This is again represented as R of t is equal to a into it is t square by 2. This is for t is greater than or equal to 0, and it is 0 for t is less than 0. That is the definition for a parabolic signal. It is the parabolic signal can be represented mathematically like this. This is the mathematical definition. This is the mathematical definition. R of t is equal to a into t square by 2, and this function is exists for t is greater than or equal to 0. This means 0 to up to plus infinite. So this is the starting limit. It is the starting limit t. Okay, so it starts from 0 up to infinite. It goes on, and within that range of time, the function is given like this only. R of t is equal to a by t square by 2, and below t is less than 0, and this function becomes 0. So graphically, this can be represented as like this. We can represent the 0, and this is the time axis on as where it is time, and this is whatever R of t, and normally it goes like this. Like this, it goes like this. This is what your parabolic. This is your parabolic nature basically. Its signal represents like this. It goes on like this. Okay. Then this is what parabolic signal. And the special type, the special case of parabolic signal is a unit parabolic. Okay. Unit parabolic. The special case of this parabolic is unit parabolic. The special case. The special case of this parabolic signal is unit parabolic. It is unit parabolic. What is unit parabolic signal? What is unit parabolic? Same as we have seen in previous, ramp signal. Unit nothing but your magnitude becomes 1. Means in unit parabolic signal, you have your R of t is equal to, there is no a. It is simply you write t square by 2 only for t is greater than or equal to 0, and it is 0 for t is less than 0. That's all. So in unit parabolic, need not to mention a. Need not to mention a, because unit means a value becomes 1. A value becomes 1. That's why R of t square by 2. This is unit parabolic. Or this is in general. This is in general. Now, what is the Laplace transformation of this parabolic signal? What is the Laplace transformation? If you apply the Laplace transformation, then what? Laplace transformation of parabolic signal is equal to, how it becomes? This implies Laplace transformation of your R of t is nothing but Laplace transformation of, what is your R of t? It is a into t square by 2. Is it not? This implies a is constant, and by 2 is also constant. Take a by 2 as outside, means a by 2 take outside, then Laplace transformation of it is t square. What is the form is? It is Laplace transformation of t power n form. As we have seen the standard property, one of the important property of Laplace transformation, just now we have seen L of t power n formula is there, no? Therefore, you apply that, it becomes a by 2 into, as per, if you apply that property of the Laplace transformation, this is t power n, means n factorial. What is n here? 2. Therefore, 2 factorial by s plus n plus 1. N, what is n value? 2. It is 2 plus 1, is it not? And this further implies a by 2 into 2 factorial is nothing but 2 into 1. 2 into 1 is nothing but 2 only. S power 2 plus 1, 3. Means this 2 will be cancelled out. This is equal to a into 1 by s cube. This is what your answer. Therefore, clear. Therefore, Laplace transformation of your r of t is nothing but Laplace transformation of a into t square by 2. This is nothing but your, directly if you write, a into 1 by s cube. Okay, this is okay. This is the answer. And for the special case, so for the unit parabolic, so Laplace transformation of Laplace, this implies Laplace transformation of unit parabolic. Unit parabolic means your a becomes 1, means L of t of it is t square by 2 only. This means same answer, but a value becomes 1, that is 1 by s cube only here. Understood? What you are observing here, tell me? If you compare the unit step or simply step and then parabolic ramp signal and then parabolic signal, if you compare, what you are observing basically? So the Laplace transformation of step signal is 1 by s, is it not? And the Laplace transformation of the ramp signal is 1 by s square, is it not? And the Laplace transformation of the parabolic signal is 1 by s cube, 1 by s, 1 by s square, and then 1 by s cube, and so on, so on. Like that it will come. This is what the Laplace transformation of the parabolic signal. Okay, so I think we'll stop today's presentation with this, and let us see the impulse function and basically sinusoidal is in general sine wave only, that we will cover in the next presentation. So today we'll stop at this junction and we'll continue in our subsequent presentation. So I think you have enjoyed this, and I hope that you understood what is a ramp signal and as well as what is a parabolic signal, and then what are the Laplace transformation of these two. Okay, so thank you one and all.